Okay, here we go, starting chapter 3. This chapter will look a little more like algebra for different parts than the last chapter. It was very different, so that might be good news, that might not be. We'll just kind of work through it and see. This chapter is a little shorter than the other ones too, so we won't take too long going through it. So before we begin, a couple things like parallel lines. You probably know the definition of parallel lines to be something like lines that don't intersect. And that's fine, but we just need to expand on that a little bit. Not only are they lines that don't intersect, but they are also coplanar, meaning they're on the same plane. An example of parallel lines, you might have these lines drawn out. And if I look at these, and if I want to show that they're supposed to be parallel, I drew them a little wobbly. But what I would do is I would put a couple little triangles in the middle of them to show that those were supposed to be parallel. And then you could also write out a little statement. If this is line L and this is line M, I can say that line L is parallel to line M. And that would let me know that also. For skew lines, the reason why you needed to say that parallel lines are coplanar is because skew lines are also lines that don't intersect, but they're not parallel because they're not on the same plane. I'll just write they're on different planes. So for example of that, if I have a couple different planes, like maybe these two planes are like two shelves on a bookshelf. And I have this line here on that plane, and I have a line going a different direction on another plane. Those lines would be skew. And with this picture, I actually drew a picture of parallel planes. Parallel planes don't intersect. So some of the questions are just going to get you looking at this vocabulary, and they'll have some sort of diagram here, and it will say things like, list all the segments that are skew to BC. So if I kind of trace over where BC is, everything that's skew will be on a different plane, and it won't intersect. So for example, like DE, AF, what else do we have here? HE. And the last one would be GF, are all skew. Sometimes students think that this line here, FE, would be skew also, but that one's actually parallel. They show that to you over here in this picture. That's from your book, how you could have a plane that kind of goes through diagonally through that cube, and they would be parallel, even though that plane's not drawn into the picture. For the next one, I'll just kind of erase those real quick. For the next one, everything that's parallel to EH, it actually only asks you for a segment instead of all like the last one did. A segment, you could go with CD or FG, or even AB. All of those would be parallel. And then for this last one, all planes that are parallel CH. So DCH is this plane here on the kind of right-hand side. I would say that the plane that's parallel to that is FAB. Or you could include the letter G. You could include all four. I wouldn't mark that wrong, but you really only need 3 points to define a plane. The fourth one is just writing it out extra if you want to. This next part, these are 4 pieces of new vocabulary. It kind of looks like a lot, but if you can think about what the difference between interior means, interior being like between things, so between the lines, and exterior being not in between the lines, it kind of cuts the vocabulary in half, so it might not be quite as bad as it originally looked. So looking at this, consecutive means like right in a row. Like if you talked about like the football team has so many consecutive wins. That would be right in a row or right next to each other. So consecutive angles in this picture are going to be on what's called the same side of the transversal. The transversal is this line here, line T, the line that transverses between the other two lines. So they're on the same side of that, and they're both on the interior. So an example of consecutive interior angles would be like angle 4 and angle 5. Would be consecutive interior angles. Or there's another pair, angle 3 and angle 6 are also consecutive interior angles. So if you're taking notes, make sure that you draw this picture out. You need to pause it or whatever to get those angles in the same spot so that when you're naming them, you have that information just kind of right there in front. And even if you want to, like if it'd be more helpful to you to maybe put like this is 4 and this is 5 and not have all the other angles on your picture for this one, sometimes students like to see that a little more for each one as we're kind of getting to know which ones are which. So for the next one, for alternate interior angles, again, interior will be some of these green ones here. To alternate means to be like on every other side. So these are on different sides of the transversal. And they're both on the interior. So looking at the picture here, angle 4, its alternate interior angle will be angle 6. And then for angle 5, its alternate interior will be angle 3. Once you have these down, or alternate interiors, alternate exteriors are the same thing except both on the exterior. So I'll write that down quick. They're different sides of the transversal and both on the exterior. So looking at this picture, angle 1's on the exterior. The one that's on the alternate side would be angle 7. And then also angle 2 and angle 8 are considered alternate exterior angles. And then the last set here are corresponding angles. For corresponding angles, the definition says that they are on the same side of the transversal, and you have one on the interior and one on the exterior. I like to think that they just correspond. They're in like the same corresponding position. So maybe they're both like on the upper left-hand side if you look at those intersections. So angle 1 is on kind of like the upper left-hand side if I'm looking at these 4 angles grouped together. And the one that would correspond from the other intersection would be angle 5. So angle 1 and angle 5 are corresponding angles. 2 would correspond with 6. We have angle 4 corresponding with angle 8. And then the last pair would be angle 3 and angle 7. Okay, I know I don't have these things typed out, but don't forget about your vertical angles and linear pairs from the last chapters. We'll still be talking about these, so these might be answers to questions. Vertical angles, an example might be like angle 2 and angle 4. Or a linear pair might be angle 7 and angle 8, like these two here. So those will still be answers to some questions. This chapter, though, we're kind of focusing on some of this new vocabulary. So this is the way the questions are going to look. The questions will say things like, classify between the angle pairs, what type are they? So what I do is I look at the picture and I find where these angles are. So angles 2 and 6, because they're on the same side of the transversal C, but you have one on the interior, one on the exterior, these are corresponding angles. Or you might think like they're both kind of on like the lower right-hand side. Looking at angle 1 and angle 7, those are on different sides of the transversal, and they're both not in between those lines A and B. So these are called alternate exterior angles. Let's do the next one. The next one we have 3 and 8. So those are on the same side of the transversal C, and they're both on the interior. So these ones are called consecutive interior angles. And then lastly, for this example, we have angle 3 and 5. And those are both between or on the interior of those lines and on different sides of the transversal. So these are called alternate interior angles. And then for this last set of directions, this gets a little more tricky when we don't just have 3 lines in the picture. Maybe we have some more. The directions here ask us not just to tell what type of angles they are, but also to identify the transversal connecting the pairs of angles. And then we want to classify them. So when I'm looking at example A, where I have angle 1 and angle 2, the transversal is going to be the line that like kind of cuts through both of those. So the transversal in this case is line V. And then it might help you if you want to like kind of extend that out to see what type of angles these are. These are on the same side of that transversal, but one's on the exterior, one's on the interior. So these are called corresponding angles. For the next one, looking at angles 2 and 3, if you kind of maybe trace over those angles, angle 2 and angle 3, well, the line that kind of cuts through or touches both of those is also line V right here. So line V is the transversal, and then these are on the inside of those other 2 lines, X and then S. So these would be called alternate interior angles. And you'll see me start to abbreviate. I told you I like to abbreviate things. And then for this last pair, angle 4 and angle 5, the line that kind of cuts through or touches both of those is this line right here, and that's line Y. And then these ones, if you're looking here, are both on the interior between those other 2, W and T, and they're on the same side of the transversal. So this is called consecutive interior angles.